All right. Well, hello, everyone. My name is Adriaanse, and I'm going to be talking about doing some training on audio. This presentation is split up into two parts. One is just talking about audio fundamentals, just to get a basic understanding, and the second half will be training specifically on Techlahoma's audio setup here in Star Space 46. So just a brief note about me. Again, my name is Adriaanse. I've got my my work and my personal email address on here, my Slack account if you want to get a hold of me. I'm a software engineer full-time at Osberg, so that's my day job, but I've also been running sound for live sound for mostly for various churches for the past 10 years. So in the process, I've learned a lot, and it's been a lot of fun. And so kind of wanted to take what I've learned and share it with you guys. So I'm also currently a sound engineer on the side over at Bridgeway Church. So the goal of this talk is to, for those that are interested, give more information on how audio and audio equipment works. But overall, running sound is something that's, especially for more complicated systems, is something that takes a lot of experience. And it's very easy to mess things up. So I'm going to give you some tools today to understand what's going on, but with the caveat that it's probably best to minimize, if you're not real familiar or real experienced with audio, it's probably best that you minimize any change that you make, because it can actually make things worse without knowing it. So, all right, so a little bit of physics. In the audio world, you hear a lot about decibels. Basically, it is we use that as a logarithmic scale to describe changes in audio levels. Technically, it just refers to changes in ratios. It doesn't have to be audio. It could be electricity. It could be something else as well. But essentially, with decibels, you express the ratio between a before and after a change in terms of you're adding a certain amount of decibels or you're subtracting it. So when you're adding decibels, for example, you're adding 10 decibels to a certain level, you're essentially, you're significantly increasing that level. And on the next slide, I'll show you an example of what exactly 10 decibels means. But you can see the formula here to convert ratio between intensity 2 divided by intensity 1, or how to translate from decibels to the ratio and vice versa. And also on the next slide, you'll see there's actually two columns, one that refers to power and one refers to voltage. Just know that power is voltage squared. So if you have a doubling in voltage or doubling in signal, you'll actually end up with 4 times the amount of voltage, as an example. So when you've got an audio signal and you're subtracting 3 decibels, you are essentially cutting the voltage signal by 1.4, dividing it by 1.4, which is the square root of 2. And you're cutting the power in half. Likewise, if you're adding 3 decibels, you're doing the same thing, but you're multiplying the voltage by 1.4, the power by 2. 6 decibels, you're doubling voltage, quadrupling power. And so essentially, when we're talking about audio levels, sound pressure levels, or voltage levels, in real life you're multiplying, but the way you express it in decibels is you're adding or subtracting. So if you're adding 10 decibels to a signal, you are essentially increasing the power by 10 times, but the way our ears work, it's actually perceived as twice as loud. And then same thing with, if you're adding 20 decibels, you're making it 4 times as loud. And so, yeah, and the one other thing I forgot to mention is that on Decibels generally are relative. So when you say something is 85 decibels, that means nothing. Now, there are reference points. For example, you may have a reference point in voltage, called dBV. Or for sound pressure levels, a common reference point is something called A weighing or C weighing. And you'll see dBA, dBc. So 95 or 100 decibels, or dBA, dBc is quite loud, but you always have to put that in the context of some type of reference point or some type of weighing. All right, so one more element of physics before I move on, and that's the inverse square law. So the inverse square law says anytime you are you're doubling the distance between the source of audio and the receiver, like your ears or a microphone, you're essentially cutting the levels in half and cutting the power into 1/4, which is a -6 dB increase, or decrease rather. And likewise, if you cut the distance in half, you add up, your signal adds 6 decibels, at least in theory, in a free field with a point source. So in practice, it may not always be exactly that, but it's a good guideline. So just to demonstrate, so right now I've got maybe 2 inches between me and the mic, and I'm going to just double that, and you can see all of a sudden you don't hear me very well. And now I get closer, and now I'm much louder. So all that to say is that it's very important to keep the mic as close as possible to your mouth. If you don't, then you have to turn up the mic on the board a lot, which is not only going to increase the volume of your own voice or of the presenter's voice, but also everything else in the room, and increases your risk of feedback. So always try to keep the mic as close to the presenter as possible. So feedback, what is feedback? Feedback is essentially a loop between sound coming out of the loudspeaker, then the mic picking it up, then the sound system amplifying it, sending it back to the loudspeaker. Now generally there's always going to be feedback. Right now, some of the sound coming from these speakers to my right and to my left are being picked up by this mic, but because it's not being amplified a lot, and because I'm close to the mic, and therefore I don't need a whole lot of amplification, you're generally not going to hear it. But if the amplification levels get close to where the sound coming out of the speakers is, and then being picked up, and then making its round through the sound system, the second time it goes around, if it's almost at the same level as what it was in the first round, then you'll start hearing ringing. It still dies away after a while, but it's kind of an obnoxious sound. And then if you increase amplification even more, where it actually, the second round, the audio levels are louder after having traveled through the sound system, then you'll have full-blown feedback. So I may try to demo that. So I don't know if my gains are high enough, but let's see what happens here. You hear that? The ringing? It's pretty bad. But it's still, it's on the verge of getting loud. So anyway, but even if I've got to turn down just a little bit where it's not ringing yet. But you can hear, especially on the stream, I don't know if you can hear this one in the room, but you can already start hearing some ringing. So it's, instead of being far away and having the amplification turn up, it's much better. It sounds much nicer if I'm close to the mic and I've got the levels down. Another thing that, I don't think we see this a whole lot here, but sometimes, especially as singers, they like to cup the mic. It's fine to hold the mic with your hand here, but to cup it, it completely changes the sound, and it sounds terrible. Sometimes, it may be an artistic effect it may be going for, but generally, the hand should always stay clear of the grill. Okay. And also sometimes the audio levels may be high enough where the system is prone to feedback, but you may not hear it until you actually kind of prime the sound system, like you make a sound that it gets picked up by the mic. So if I were to turn it up right now and not say anything, I don't know if this would work. Check. Check. You can hear it kind of triggers the ringing. So, all right. So how do you avoid feedback? So there's a few. Really, the solution is simply turn down amplification. There are fancy things like feedback suppressors that I think that they may sometimes work. I've never really used them. But really, the best and the most reliable solution is turning down amplification. The only problem with that is that, if you turn on amplification, people may have a hard time hearing the speaker. So what do you do about that? Well, you increase the source level to compensate for the lack of amplification. So you ask the speaker, the presenter, to speak louder. And that usually doesn't work very well, because when you're in the middle of a presentation, you're not going to be thinking about, most people are not going to be thinking about how loud they're speaking. So, or they may start off louder and then they kind of revert back to their natural volume. So the best way to do it is just to get real close to the mic and either ask the presenter to get closer to the mic or bring the mic closer to them. Okay, one other thing, polar patterns. So microphones have a specific pattern where they pick up sound from, like, in other words, directions that they pick up sound from. So you may have an omnidirectional microphone that picks up sound from any direction. The sound could be coming from behind the mic, from the sides, and it'll just pick it up equally. You can see here. It might be kind of hard to see on this presentation, but right here, this part right here says 0 decibels, -5 decibels, -10 decibels. So this solid black line shows you kind of how much the sound is suppressed depending on the direction. So 0 decibels means it's not being changed at all. Cardioid mics, and I think this mic is a cardioid mic, if I remember correctly. It basically, so this is the front. The top of this diagram is the front of the mic. So it picks it up full strength in front. But as you start going to the side, the signal level drops. So if you're at 90 degrees, the signal level drops by 5 decibels. If you go to 120 degrees, it goes to -10 decibels. And if you go all the way behind it, then it doesn't pick up anything at all. So in other words, this mic right here, because it's a cardioid mic, at least if I remember correctly, it will reject all sound coming from the back. So I'll demonstrate that real quick. So I'm going to just be talking. I'm going to be turning the mic, and you hear very little. Talking from behind it, there is nothing, almost nothing being picked up. I'm not perfectly behind it. And as I go on the other side, it comes back on. So why is this relevant? Well, it's important to point the mic at the speaker. So if you're setting up a mic and you're pointing it this way, first of all, it's too far away. You can see here. Second of all, even if we were to bring it close, it's not going to be picking up very, very much unless I turn it. So distance between the presenter and the mic and the direction that the mic is pointing makes a big difference. Also, putting the mic, I don't know if you can see it on the camera, but putting the mic on your chest is not going to do a very good job picking up the sound level, or on your forehead. It needs to be where the sound is coming from, which is your mouth. And then there's also a supercardioid microphone, which tends to reject audio from the sides a little bit more aggressively. So if you're at 90 degrees, it's a -10 decibel drop. If you're at 120 degrees, it picks up nothing. But there's a little bit of a lobe on the back where it does pick up a little bit of sound in the back. It's not a whole lot, but it's some. So. And the same, by the way, also goes for loudspeakers. So especially high-frequency drivers in a loudspeaker, those tend to be very directional. So if you're standing to the side of a loudspeaker, you're probably not going to hear the higher frequencies very well because you need to be standing in front of it. In other words, and that's why the loudspeakers here are pointing right at the audience, not pointing at a wall or pointing at me. And now lower frequencies, that's a little different story. As the frequency goes down, it becomes less directional, and then kind of like especially really low frequencies like a subwoofer, it just splatters everywhere. You can't really control where it goes. Anyway, that's a side note. Also, more is not necessarily better. So if you have someone that's got a mic, and let's say they're also having a mic for the audience questions, which I'm about to grab. I'll be right back. Okay, right now I'm talking on the audience mic. And I'm back on the main speaker presenter mic. So if the presenter accidentally, has the mic in his hand and he starts talking like this, it does not sound very good. So the reason why it sounds bad is because of something called the comb filter effect. And basically, you have sound coming through, being picked up by two different mics, being mixed together, but the sound is not exactly aligned because one mic might be slightly closer than the other mic, and therefore, so it's going to be, because time travels at a finite speed, it's going to be a little bit delayed on the second mic. And when you have waves, two waves that are the same waves, but they're when one of the waves is being delayed, it causes destructive and constructive interference, and your frequency response might look something like the graph that's on this chart. And same thing if you have two loudspeakers that are pointing to the same person. You've got the exact same audio signal coming through it, but one loudspeaker slightly louder, it's not going to sound very good. Now, that does not apply to stereo music, for example, because with stereo music, you actually have different sound coming from each speaker. So just to demonstrate real quick, I'm muting my mic here, and I'm going to bring it close, and you'll see that that was interference. You'll see that okay. You'll see that the sound quality changed as I bring it closer, including the type of interference you get. So I'm going to be talking here, and check 1 2, check 1 2, check 1 2. So anyway, all right. One other thing, cables. So in the audio industry, professional audio, they have something called balanced cables, which is really cool. Most common balanced signal or cable that's used for carrying balanced signal is the XLR cable, which you can see right here. So the XLR cable's got 3 pins. One is ground, one is hot, and one is cold. Now, with a balanced signal, the same signal is being carried over two of both the hot and the cold wire, but on the cold wire, it's inverted. And then whatever you plug it into, which may be a mixer or amplifier, it basically subtracts the two signals. And because one of the signals is inverted, it actually amplifies or doubles the signal. You might be wondering, well, who cares? Well, the nice thing about it is that if you have interference, so sometimes cables can act as a big antenna, can pick up noisy electronics from around it, such as fluorescent lights. That same interference is going to be on both cables, but because they're being subtracted, it actually cancels out. So that's really nice. There's also popular cable in professional audio is the 1/4-inch cable. This is a TRS or tip ring sleeve. It's got a tip, a ring, and a sleeve. It can be used for carrying balanced audio as well because it has 3 connectors, or it can be used for carrying stereo, or sometimes used for inserts, lots of different purposes. Below is a tip sleeve cable. It only has 2 wires and therefore cannot carry balanced audio. So the ring on both cables is for the ground. So for this one, it's just going to be just unbalanced audio. And then, so here you see the 1/4-inch cable, 3.5 millimeter cable. Usually those will be tip ring sleeve as well, but it's used for carrying stereo. So the tip will be left channel, ring will be right channel, and then the sleeve is the ground. Okay, so next I'm going to be talking a little bit about signal flow. In particular, I've got pictures of the equipment that we have here at Techlahoma. So we start off, this is the mic that I'm talking into right now. That's being picked up by the receiver that goes into channel 1 of this new fancy mixer that we recently got. And this mixer, like the name implies, it mixes audio. I know, it's quite a shocker. And from this mixer, it sends out 2 different audio signals. One is coming out of the mains, and it's going to the 2 loudspeakers that are to my left and right. And then the other one is actually, it's called the aux output, or auxiliary output. That one's going into the camera. There's an audio input on that, and the camera sends that signal via HDMI to the computer that we use for streaming. So that way we can actually have 2 separate mixes for what we hear in the house here, in this room, versus what is being streamed. Let me see what I want to say about that. Okay, so one thing I've tried to do when setting up this equipment is have a proper gain structure where the gain coming out of each piece of equipment, whether it's a microphone or a receiver or the mixer itself, is nice and strong. That way anything downstream does not have to amplify this audio level a ton. I'm going to turn this mic off. I don't know if it's the guest mic that's interfering, but anyway, so so that way you don't amplify a bunch of noise in the process. So, and then at the last stage, we've got the loudspeaker or the amplifier that's in front of the loudspeaker, and you can use that to dial down the volumes to the appropriate levels to make sure it's not blasting your ears. So you want a hot signal going into your amplifier, and then amplifier, you can turn that down. So really anything that we've set up here is not really meant to be adjusted, so you should never have to go into the loudspeaker here and adjust the levels there. Really the only levels you should have to change is just in the mixer itself. Oh, and then the other thing that I keep in mind when setting signals is that I want to make sure I have plenty of headroom. And what that means is the amount of room, the amount that the signal can increase before it starts clipping. So clipping sounds bad, or is bad. It's when you're basically overloading the circuitry or digital signal processing, and it cuts off the waves and it sounds distorted. So if you're wondering what it sounds like, I might be able to demonstrate. Let me save my settings here real quick before I mess it all up. So this right here is the mixer that we're using here at Techlahoma. I'm connected to it via our wireless network, and so I can control it remotely from my laptop, which is really nice. So all right, so I'm going to turn down the volume, so you're not going to be able to hear me for a second. I'm going to turn up the gain. And let's see. Wow, that's really loud. I don't know if you can tell that it's clipping. Yeah, I can hear it now. Anyway, that's what clipping sounds like. You do not want clipping. So let me just restore settings real quick. 1 second. All right, now it's back to the way it was before. And I'll talk about snapshots in a minute. So essentially, you don't want the signal so hot that where it's always close to clipping, even if it's not clipping, because all it takes is for someone to get really excited and it'll start clipping. And you may not, when you're testing audio, you may not always realize or see truly see how loud the signal or the source is going to get. All right, next is a block diagram that I pulled from the mixer that we've got. This is from the manual. It's towards the back of the manual. I personally really like looking at these. I don't know if anyone else does. It can be very intimidating, but it's actually, once you get the hang of it, it's actually really not bad, and it gives you a good overview of how signal flows, which is really helpful in troubleshooting problems. So you can see here, audio. I know it's going to be hard to read, but it's the audio is going to be coming in here from the input. In this case, there's a microphone input. It goes through. There's some signal processing that happens. So it cuts off the lower frequencies if you choose to do so, which we do, because that's nice. It goes through a gate, which basically mutes the let's see here. So the gate will essentially mute the microphone that if the levels are too low. So if you have a noisy source, it can actually mute it when the source is not actually emitting any sounds besides noise. So after that, it goes through EQ, it goes through compressor, essentially a compressor. If the volume gets too loud, 1 second. Kind of had an emergency come up. So after that, so the compressor will turn it down if it's too loud. Then there's a mute switch, which kills the sound for that particular channel altogether. A fader, which turns the sound levels up and down. And I forgot to mention, if you set a fader to 0 decibels, it means it's not increasing nor decreasing the sound. It's just letting it pass through untouched. And some other things, and then it gets sent to both the bus as well as the mains. So the aux bus, is what goes to the streaming PC. You can see it. It goes down here, and then it's got some more signal processing as well as a fader at the end. And then the mains is what's going to the, right here, through the stereo. And again, you can see some processing there, and then it goes out to the output of the mixer onto the amplifier that's built into our speakers. So, all right, so I'm going to do a quick demo. It may not be quick, but I'm actually going to be showing what we're doing here. So you can see here. So here's our mixer. So this is the mixer that we got is a fairly low-cost mixer. It's about $250, $300, but it's incredibly powerful. It's got all sorts of really cool processing. So it's an incredible value. So there's a lot of things you can do with this mixer. I recommend, unless you really know what you're doing, you stay away from it because it can be quite intimidating. But obviously, in the process of streaming things for Techlahoma, you will need to be making some adjustments. So the first thing, actually, let me disconnect. Let me close the app and show you what it looks like when you start it up. So when you first start it up, it'll ask you if you want to connect to the mixer. And by the way, we've got the same software installed on the PC that's used for streaming. And I'll show that in a second. So you hit connect. And it'll ask you if how you want to synchronize. You always want to synchronize from the mixer to the PC. So at that point, it basically copies all the settings over to your computer or to the app. And at that point, now you can see me talking. You see the levels right here. The screen you'll be in most of the time, and you may not ever have to leave, is the mixer screen. There's also other screens like channel, input, etc. But mixer is really where you want to be. And maybe also in the meter screen. Meter shows you the different levels, and that's actually really helpful for debugging or troubleshooting. So I'll get to the meters in a second, or the troubleshooting in a second. Oops, I did not mean to do that. My bad. So, so we've got, so in the mixer, this mixer has 16 inputs. Actually, I think it might have 12 inputs, but the software shows 16. Right now we're using 4 of those inputs. Channel 1 right here, it's got a label right here. You can see that. Handheld, or HH, mic 1, and that's the mic I'm talking into. That's the Shure mic that we're using for our presenters. And then there's handheld 2 mic, which is the one I'm holding right here. That's a Samson mic, and right now it's turned off. That's why you don't see a signal, even if I tap it gently. And then channels 3 and 4 are currently not used. We may use them in the future for head-worn mics, but that's to be determined. And channels 5 and 6, these are sound coming from the PC. So if you're playing something on the PC or a presenter is playing something, you can turn it up here. And you can see that channel 5 is the left channel, channel 6 is the right channel, and when you turn it up, they both automatically go in tandem because the 2 channels are linked together. So, so really, those 3, 4 faders are really the ones you'll probably ever need to touch. So if you want to turn down this mic if it's too loud, just take your mouse and drag it up and down. You can see it's not very loud now, and it's getting louder and louder and louder. And then also, there is this fader all the way on the right is a fader for the main. So this fader does not change anything as far as volumes going to the stream. It just changes what's in the house. So if the house is a little too loud, but the stream sounds great, you can turn this down a little bit. And right now, people can still hear me in the stream, but not in the house. Okay. Before I forget, here's a bunch of buttons. Essentially, this mixer supports multiple mixes that are independent from each other. That's what these buttons here are for. So, for example, if you press on bus 1, you can actually control what's going out to the stream without affecting anything that's in the house. And you can do this on a per channel basis. So if I make a change here, it does not change. For example, if I change, channel 1, it's not going to change anything with the house, only the stream. However, I recommend you do not get into these bus buttons because it's very confusing, because you may make a change here, and this has happened to me countless times. You may make a change here and then forget to put it back on main, left, right. And then 5 minutes later, you may want to change the levels in the house, and you're changing it, and nothing seems to be happening. But something is happening, but you're changing the wrong thing. So if you do accidentally click on one of these and you want to get out, and you can see that, you can tell that when you've got this thing, one of the buses selected because all the channels have a outline in a particular color for that bus. If you want to get out of that, just press main, left, right. So you always want to be in main, left, right. You do not want to be in bus 1 or anything else, or effects for that matter. All right, so for each channel, there's a bunch of processing. I already kind of talked about it. Basically, when you click on a channel here, and you have the channel section open at the top, whatever you click on here shows at the top. So right now, if I click on handheld 1, any changes I make here only apply to handheld 1. And real quick, 48 volts, that's phantom power. We do not use that here. You should never turn it on here. Those are used for condenser wired microphones, and we don't have those here. So basically what it does is it sends 48 volts over the microphone cable to power a condenser microphone. And if you send 48 volts to equipment that's not designed to handle it, most of it will be fine, because it's designed to handle accidents. But there's some equipment is not designed to handle it, and you could actually fry it. So always want to stay away from the 48 volt button. Polarity, it basically inverts the signal. You should never have to mess with that. And then the rest on the right side is basically shown in more detail if I click on the buttons here. So input, you can change the gain. Essentially, a gain is an amplification that happens right before the audio, in the case of this mixer, before the audio gets converted to a digital signal. So you should not have to really mess with the gain unless you're seeing that the channel is clipping. Then you may want to turn it down. But I've got it set up in such a way where it should be pretty much impossible to make it clip. So the gain should always just be just left alone. Low cut filter, it cuts off any frequencies below 178 hertz, so it makes the voice less boomy. Gate, already talked about it, it's kind of like an auto mute. EQ, there's certain frequencies that we cut out a little bit to make it sound a little nicer. And if you want to know what EQ does, I can demonstrate by taking this one and dragging it up. And you can see it sounds really weird. And as I go lower in frequency, you can hear the amplification for that particular frequency change to a different signal. So let me put this back to 0. And we're also cutting off some high frequencies as well, because they're not really needed. Compression, essentially, I can demonstrate right here. Let me turn off compression. So if I speak quietly, and if I speak loud, it's really loud. And if I turn on the compressor, if I speak quietly, and speak really loud, you can hear it's starting to squelch, or turn down the signal when it gets loud, and then when I stop being loud, it brings it back up. So it helps reduce the dynamic range a little bit, and basically keeps the quieter sounds more in line with the louder sounds. So that way, if someone all of a sudden just coughs into a mic or something like that, people's ears don't get blown, which you always want to avoid that situation. And then sends is basically what sends it to bus 1 and bus 2, which is what we're using, which is what we're sending to the streaming PC. So again, you should not, really any of these buttons right here, you should never have to touch. I'm just telling you if you're curious and you want to at least have an understanding of what it does. And yeah, all right. One other thing. So I've got, on the right side, you'll see a snapshot button. Basically, these digital mixers allow you to save all your settings to something they call the scene. In this case, it's called a snapshot. And you can recall it at a later time. And there's lots of different snapshots that you can store it under. So if you're having problems, the mixer's behaving weirdly, it's possible that someone before you might have been messing around with settings and messed things up, which tends to happen with audio equipment. I don't know why, but it does. So if you want to go back to some last known good settings, you just click on Snapshot, you select the good settings, and you press load, you confirm, and now it puts everything back the way it was now. Also, there's also a save button. You should not use that. So only I get to use that, and other people who are experienced with audio. So because you don't want to make changes, potentially mess things up, and then save those changes. That would really confuse people. All right, so let's talk about troubleshooting, which is probably the most important part of this talk. So what do you do when you're not getting audio? Well, you basically go down, just follow the signal flow. You start with a microphone. First thing you do is you check. Let me pull up my presentation real quick. You check on the receiver right here. You look and see right there, it's got a little bar that shows you when there's signal. If you're talking to the mic, but you're not getting signal, the problem is probably somewhere between the receiver and the microphone. Maybe it's not turned on. It's always a good thing to check. Or maybe it ran out of batteries. So if you're getting signal from there, the next thing is to check the mixer, because that's what the microphone is plugged into. So Going back to the mixer. So I told you about the meter section. Let's go ahead and press that. So over here, you got the analog inputs. So these are all the channels going into the mixer. So channel 1 is the mic I'm talking into. Channel 5 and 6 is the audio PC. If you're not seeing a signal there, maybe a cable is unplugged. Or, you know, in the case of the channels 5 and 6, maybe the audio output on the computer is not working. If you're seeing a signal there, then you know the mixer is getting a good enough signal, and you look elsewhere. Well, if you're not seeing anything in the main, so if this fader over here is not moving, then you know somewhere inside this mixer, the audio signal is getting dropped. Maybe it's getting muted, so if I mute it right now, you won't hear me. So make sure it's not muted, make sure the volume is up. Also, check to make sure that the volume of the speakers is up and is not muted, because if I mute it, the stream will still be able to hear me, but the speakers will be off. So check for that. If there is signal coming out of the mains, but there's no signals coming out of the bus, then you'll want to, this may be the one situation where you do want to click on bus. So if you click on bus here, this volume right here is the kind of the master volume for that particular bus. So you want to make sure that's turned up all the way to 11. That's a good level to put it at. And make sure it's not muted. Make sure these faders are up. They should be. They should always be up. If they are not up, it means someone got a hold of this mixer and had fun. And so if you're seeing signal coming out of the two bus outputs, which is what's being sent to the PC, then you know that the problem is probably not with the mixer. Now, the way we've got things routed, and I think I explained this before, is we have the audio coming from the mixer going to the camera. On the camera, there is, on the screen at the bottom, there are some bars that will move if it's getting signal. If you don't see those moving, maybe there's a bad connection, or rather, maybe a cable got unplugged. So check that. If the camera is showing that it's getting good audio signal when you're talking into the mic, but the streaming PC is not showing anything, then it's time to check within the PC, because the audio is being routed via HDMI. Maybe OBS is not using the right source for audio, or maybe it's muted there. So there's lots of things to check. And let me see if there's anything else I wanted to talk about here. No, I think that just about covers it. So I'm going to switch real quick. Actually, I'm going to switch, move away from the lectern here and go to the computer back there and show you what things look like over there. Because what I've been demoing is the software running from my laptop, but we also have the software running on the computer, the PC that's back there, that's used for streaming. So I'm going to go over there right now. Okay, gotcha. All right, so I am back here now, and I'm going to switch to, I'm going to switch to this right here. So you can see OBS right here. The mic, the audio from the mixer, which is going into the camera and then being transported via HDMI into the computer, should be going into mic aux. If it's not, there may be a problem. Sometimes what I do is I go into settings and look at audio, so mic aux audio device should be set to this one right here, the 001 Pro Capture Quad HDMI. Sometimes things get mixed up. Sometimes restarting OBS fixes that problem. Other times you might have to go into the settings and make sure everything looks good there. And I think most of you who have been trained on OBS know that this slider right here will turn up the volume. But I think the way it's set up right now, especially now that we're using compression on the mixer, you probably will not really need to adjust it much, but there may be some times where you have to. You kind of want the audio to go into the yellow zone, never into the red zone. So, and of course, you want to make sure it's not muted. If it's muted, you'll see that the speaker symbol is red, like it is over here. And let's see here. So that's OBS. Let me pull up the mixer on a different window. Give me 1 second. Where is it? Lost my monitor. Oh well. Well, I'll just bring it over. It's no big deal. No, I'm trying to get to the second screen on the streaming PC here. So I'll just drag it over. So on the taskbar at the bottom, you'll see there's an XR icon. And let me just close the app right here. I'm going to click it. So this is how you control the... well, let me just move this. This is how you control the mixer. So there is... Hold on 1 second. Again, first time when you start this application up, it'll ask if you want to connect. The answer is yes. It'll ask if you want to synchronize. The answer is mixer to PC. That way you're not overriding any settings that are on the mixer. And again, what we've got here is the exact same thing that I had on my laptop. So whatever you do here, it looks just like I did on my laptop. And I think that just about covers it.